So we're now going to look at another component of our weather systems. We're going to look at clouds. Now we all know what clouds are, those fluffy white things in the sky. But let's have a look at why and how they form. I'm going to take a bit of a deep dive into this. So, what is a cloud? Well, cloud is just moisture vapor that has condensed so that we can see it in the sky. So, we can express that as air contains water vapor. As we saw in the discussion of the water cycle, air is evaporated off the oceans and anywhere else on land and rises up as water vapor into the air. So we say that the air can hold water as water vapor. When that air condenses, it comes out of that water vapor status, and we see it as little droplets in the sky. So that's what we call clouds. Okay, so let's have a look at this principle of air being able to carry water. The amount of water vapor that can exist in a volume of air depends upon the air's temperature. So at lower temperatures, the air can only hold smaller amounts of water. So for example, looking at this graph here, at 0 degrees centigrade, air can hold about 4 grams of water per kilogram of air. But if we warm that air up to about 40 degrees centigrade, then the amount of water that the air can hold increases to around 47 grams of moisture per kilogram of air. If the air holds more moisture vapor, or if the amount of moisture vapor that exists in air is greater than the air's capacity to hold that water vapor, that's when you get condensation and you get clouds forming. Now we can have a look at this by looking at relative humidity. So air does not always contain the maximum amount of moisture vapor that it can hold. It often contains less than that. And the amount of water vapor that's actually in the air compared to the amount that it can carry is what we call relative humidity. You've all heard of relative humidity. It's forecast. It ranges between a few percent up to 100%. You all know what it feels like when it gets up to that 100%. Okay, so what is it? So it's a convenient way of measuring the amount of water being held by a volume of air. And very simply, we can express it in this fancy formula, which is just rho divided by rho, and rho means here the density of air, but we'll just use it to mean the amount of moisture vapor in the air, which is the first one, rho v, divided by rho v asterisks, which is the maximum amount of moisture vapor that air can carry. Okay, times 100 to give us relative humidity expressed as percentage. Now we can also look at what's known as the dew point temperature, and this is defined as the temperature at which the moisture in the air will start to condense and form a cloud, or form droplets of air. Now we call dew that thing we see in the morning covering the grass, the moisture that's covering the grass, that's dew. But we use this term to generally describe moisture vapor turning from its gaseous form, the vapor form, into liquid form. So the dew point temperature is the temperature at which air will form a cloud. Okay, let's have a look at these two things in a bit more detail. So let's look at relative humidity and dew point temperature. If the air temperature, say at 30 degrees centigrade, is holding 15 grams per kilogram of air, right? Let's say that's how much moisture is in an example parcel of air. It's holding 15 grams of moisture vapor per kilogram of air. What is its relative humidity? Well, let's use this diagram to have a look at what is the maximum amount of moisture vapor that air can hold at 30 degrees. Well, it's around 27 grams per kilogram of air. And we've stated that we've measured, let's say, gone out and measured the moisture in the air with instruments, and we've measured that 15 grams per kilogram. So to work out its relative humidity, it's just 15 divided by 27 times 100, and we get 55% relative humidity. Okay, that's great. Now, but what is the temperature at which that air containing 15 grams per kilogram of moisture vapor would become a cloud? So when we look at that sort of reverse, we say, well, it's got 15 grams per kilogram. It's currently at 30 degrees, so that's not its maximum. So we wouldn't be forming a cloud. What air temperature would that air have to be in order for that 15 grams per kilogram of moisture to be the maximum amount it could carry? What is its dew point temperature? Well, again, we can look at this, use this graph and look at it in reverse. Here we have 15 grams of moisture vapor per kilogram of air, and what temperature is that the maximum? It's at 20 degrees centigrade. So if we took that air at 30 degrees centigrade and cooled it down, when it got to 20 degrees, it would reach its dew point temperature. The moisture vapor would turn from a gas back into a liquid, and if that occurred in the sky, you would see a cloud. If it occurred close to the land, then you would get dew forming on the ground surface. Okay, so that's relative humidity and dew point temperature. Okay.